Okay, hello people. In this video I'm going to be talking about how to write memory arenas in C++, and the reason behind it, why I implemented it, and I will go through the code as usual and try to explain how it works, and then we can take a look at the implementation and the tests that I wrote. And but first we'll start from the header file, and I guess I will put a link in the description to the code base so we can take a look. The arena itself is a part of the C++ library that I'm writing. It's like a simple C++ library which contains different data structures. For example, it has like a growing array, the hash table, the linked list, the queue, the stack, the string, and some other things which I haven't implemented yet, but they are on its way. So yeah, let's just get started. And so here is like as usual, we have a header file and the implementation file, and I want to mention that I will try to keep the video as short as possible so I don't extend it for 1 hour. If you have any questions, you can leave all the comments below, and yeah, feel free to reach out to me, or like if you don't understand something or you have any other suggestions of how to implement it better or at least differently, just reach out in the comments and I will be more than happy to take a look at that as well, because this is new for me, and then I was just experimenting on my own, and this is what I came up with. So here is the header file, and I have two classes here currently, and maybe it would be better to start with the memory arena. And I might give you a little bit of a background. So the memory arena is a technique here to manage memory allocations. So basically, it is especially used in the game development, where you allocate memory, like a giant block of memory up front, and then you split it into sub-chunks and use them as you need. So the idea behind it is that you allocate memory once, and then you don't have to do any calls to the operating system in order to allocate more memory, right? Only if you do the reallocation of arena. But you can structure your program the way that you only need one reallocation in the beginning, and that's all the memory that you requested. Like it can be 1 gigabyte, it can be 2 gigabytes, and whatever you want, right? So you pre-allocate that memory, and then you have like an abstraction layer which manages that memory. So you can use sub-chunks of that memory and try to store different data in that memory, etc. So that is like the problem that I'm trying to solve here, and later on I will be using the arena for all the data structures that I have in this library. So for example, the growing array will use an arena, the string implementation will use an arena, and some other things as well. So yeah, let's take a look at the class. I have a memory arena class here, and this is basically the class which is responsible for allocating and deallocating memory, and like managing all the memory chunks, which I explained thoroughly in the implementation file. So let's take a look. We have some const expr here. So for example, we have a page size, and I will talk about it later, and I have an allocation size, right? And the allocation size, and as you can see, it's 1 gigabyte, and this is the default size that will be allocated once you create an instance of memory arena. We make a call to an operating system which allocates this amount of memory, and we use it. Then I have a separate type. Currently is public, but it doesn't have to be really, because I never use it outside. So probably I can move it here. It's a chunk pair, and what is a chunk pair is that the arena itself, it maintains a list of chunks and the chunk can be either free or it can be in use. So here at the top of the file, I have an enumeration which says that, and I have documented everything, so you can take a look at it and on your own and just try to spend more time understanding, because obviously like 20-30 minutes is not enough. So I have the header file here, not the header file, but some documentation, and where I try to explain what this enumeration is used for. And currently it is used to mark whether the chunk is in use or it is free. And in use means that some particular chunk of memory is used by some data structure or by like some program, right, in the same process. And free means that it can be used by someone else. And when we get the chunk from the arena, and it is automatically becomes in use. When we release the chunk back to the arena, it changes the state to free. And you can see it here, and we'll take a look at the implementation shortly. But here is the list of all the chunks that I have here currently, right? And the chunk pair is exactly what I mentioned. It's just a STD pair, from the memory chunk, the pointer to the memory chunk, and then the state. And then I have things like M pointer, and M pointer is the pointer to the memory that we are going to allocate. M position is where we are in our arena, where we are in our, for example, 1 GB block of memory, and the capacity is the whole capacity that we have allocated, and in this case it's going to be 1 GB, right? So let's take a look at the constructor. In the constructor itself, what I do is I specify the size of the arena, and the default one is 1 GB. And I do some alignment because all the size is aligned by the page size. And the page size is 1 KB, right? So no matter if you specify, for example, I want 156, that would be 1 KB, because we align by 1 KB boundary, right? And the next step that we do is we say that, okay, if the alignment happened, please adjust the size, meaning that we size divide by page size. This in that way we receive the amount of bytes that are required to add to the current size in order to align with the page size, and we just subtract it, right? And then what we do, we call memory allocate memory, and this is the private member function of the arena class, and you can find it here. It's a memory allocate, and I can go to it, and what it does is actually, depending on the underlying operating system, if the underlying operating system is Windows, what it does is it calls virtual alloc, which allocates some amount of virtual pages, and then it reserves and commits them, so we can write and read to those write and read from those pages. And then I assert that memory was correct. And one thing to know that if you call in the virtual alloc, it zero initializes all the pages that you have allocated. Yeah, and for example, if the operating system is different, it's like a Unix or Mac OS, we call malloc. I don't really know what would be the call to the operating system on those operating systems, but I think malloc should work, but then we will have to use a memset function in order to zero all the memory. But you can use calloc here as well. Yes, and that would allocate memory and return the void pointer, and then we cast the void pointer to unsigned char basically. We set the pointer to our memory, so we have allocated like that amount of space, and then we set the pointer that points to that space. And then we say that here is our capacity, this is the size requested, and the size requested, and it is aligned. You have to keep it in mind. And we have like a position which is 0, and as we push elements into our arena, as we occupy more and more memory, the amp position will change, right? And it always grows. It always grows because we allocate new chunks starting from the position. But the thing that we can reuse the previous chunks, which were freed before. So that's how we keep reusing the same memory. Okay, let's go to the destructor. So the destructor, what it does, it just calls the free on the memory depending on the operating system as well. So if it's Windows, it's virtual free. If it's something else, it's just a free function because it was allocated as malloc. Here it would be pretty important. So the most important thing is this function get memory chunk, and it does all the computation in order to figure out, okay, somebody asked for the memory chunk of a particular size. What should we do? Should we create a completely new memory chunk and return it, or should we extend the current chunk that was supplied as an argument here to a function? Or, for example, we can reuse the already existing chunk which was freed, so it's in the list. Meaning that if the chunk is in the list, this list, and it has a free state, and it has sufficient amount of space that we request, it satisfies basically this condition, then we can grab that chunk and reuse it, right, for our purposes. And I will show you how it works with tests, because I'm using Google Test, and I will show you how it all works together. And later on in a separate video, I will make like a short example how to use it together with a growing array or some custom data structure, so we can see it in action actually. Yeah, I explained it pretty thoroughly here, what it does and how it computes all these things, but pretty quickly, and I have like 13 minutes already covered. So what it does, I pass the size, this is the desired size that I want to allocate, and the chunk. And the chunk is an old chunk. It can be null pointer, as you can see here, it can be null pointer as a default value. And if it's not a null pointer, it means that we either have to extend the current chunk, or we have to free this chunk and find another chunk which satisfies this condition, which has the size not less than the size requested. Now you have to keep in mind that the chunk data structure, which is here, it's a separate class which has these members, and I was thinking about whether I should keep the friend class or not, and I'm leaning towards keeping it, but I have to think about it more, to be honest. So yeah, what I want to say is that the memory chunk data structure is stored as a part of the chunk itself. So basically, if you ask, okay, I want to allocate 256 megabytes, or 256, let's start from bytes, okay? 256 bytes, then I would have to add memory chunk to that size, and then I would have to align everything by the page size. It's exactly the same technique that we were using, when we were calling the constructor of the memory arena. So we were aligning the size by the page size, So whatever, like no matter how much bytes we request, it can be either, for example, 512, and that will be aligned by 1024, or it can be 1025, and that would be aligned by what would be the next is this. So this is like exactly the size of 2 pages, which will be allocated because we exceeded the memory here for a single page. And it is quite important because this is how the architecture works of this arena, right? And the same we do for the size that we request plus the size of the memory chunk. But it is worth noting that the chunk of, like I call it the chunk header size, right? And it is appended to the size only in the case when we need to allocate a new chunk. Here I have a Boolean variable which says that if I'm extending the current chunk, and I will explain to you in a second, but basically in order to extend the current chunk, what we have to do is we should have the chunk as here and then the position. So we only need to have a single chunk in the whole arena, and that's why we can we can have more. But basically what it says is that we need to have chunk and then the position after. So here we cannot have an additional chunk because otherwise we don't have a space to extend the current one. We would have to search for a different chunk and then reallocate, right? So this is how it works, and here I set the variable extend the current chunk based on whether the old chunk is not null pointer and the position is exactly like the old chunk size plus the header of the chunk, right? So basically which says that, okay, we have chunk here, and then right after that, right after this size that it occupies, there is M position. So in that case, you can extend the current chunk up to the amount of bytes left in the whole arena itself. And then we do the alignment, right? We're trying to compute. So here we compute how many pages I want to allocate, and you have to keep in mind that it's not actually the memory that I allocate. The memory has been allocated in the constructor itself. It just here I'm trying to figure out, okay, how much memory do I need to grab from this arena in order to satisfy my request. And I can give you an example. So if size is equal to 64, then, and let's assume that we haven't provided any chunks at all, right? If the size is 64, then plus size plus chunk header size equals 64 plus 24, right? And it's going to be in total like 88. But it doesn't matter because it will be aligned by the page size. Which is 1 kilobyte. So the memory total bytes that will be allocated is this, right? And then the size that will be available for the one who requested this memory will be minus the size of the header, because as I told you before, we store the header inside the arena itself, and then we keep the pointers to those headers right here. Let me show you. So we keep the pointers to those headers right here. I hope it's clear at least a little bit, but yeah, we can talk about it more. We'll see how much time I have. I just don't want to extend it to infinity because nobody will watch it and then people will go just in frustration. But anyway, I'm kidding obviously, but we're trying to extend the current chunk. We check whether we have like the size that we requested together with alignment is less than or equal to the remaining size inside the arena. And the remaining is just a function which subtracts the capacity, position from the capacity. And then we say M position plus equals total size. So we adjust the M position pointer. And then we say that and then we have to update the total size of the chunk itself, right? And then we return it back. In this case, we extended the current chunk that was supplied here. We haven't done any, we haven't created any new chunks. It wasn't necessary because we have enough space after chunk and we could extend it. So that's all right. What if the chunk wasn't supplied or if we didn't have enough space? So what happens in that case is that we iterate over all the chunks that we have in our list here, and we're trying to find the chunk with the most which has the state, the free state, and with the size which is the most suitable for the one that we computed here, minus the chunk header size, excluding the size of the header itself. Right? So for example, if we have like, if we're requesting 1 kilobyte of size, and let's maybe not, because that's, let's maybe not say 1 kilobyte, because this is the minimum that can be allocated. The chunk of size less than that cannot be created at all, right? So what we do here is we're trying to iterate over all the chunks that we have, and we trying to find the most optimal with the size which is the most optimal, right? And here I do the size comparison and I reassign the chunk pair, and this is basically where I use the type and a couple other functions you will see in a second. And yeah, if I couldn't find the chunk with, or actually if I was able to find the chunk of a suitable size and it had a state free, I have to change the state to in use. So basically I switch to in use state, right? That's all right. And if not, I need to create another chunk, put it inside the arena, and then return a pointer to it. So I have an assertion here saying that, okay, total size should be less or equal than remaining, exactly what you saw here, right, when we were trying to extend chunk. And then I just cast the pointer. So I have like the pointer to the arena plus M position, so that would be like all the empty space that we have here, and I just cast it to memory chunk, right? Nothing special. It can be like C cast, it can be reinterpret cast, whatever you want. I just prefer having C cast. I don't see like anything dangerous about it. Yes, for example, reinterpret casts are way more easier to find in the code itself, but I didn't have problems with that. So I cast it, and then I compute the offset, because the actual size which will be available for the one who requested it will start from the M position plus chunk header size, because again you have to remember that the chunk header size is a part of all the memory that we allocate, right? And it was included in the computation here for the total size. We compute the start pointer, and the start pointer is basically will be this pointer here inside the chunk is where we will be pushing all the memory. It's like a pointer to our memory. and then we chunk size. We compute an actual size that will be available to the user who requested the size, and we say the total size minus the chunk header. And then we create an instance of memory chunk of this class, right? We create an instance of this class here. We set the starting pointer, the m size, total size, and m position, and then we write it, we reference the pointer and we write it to that memory. And then we adjust the m position of the arena, so it will bump and adjust, and it will grow and take into account that a new chunk with some size was created, right? And then we say that, okay, new chunk, and here what I will do is I insert a new chunk into the list, in this list, right? And I haven't talked about mutexes. I will save it for later, maybe for a separate session, but because the arena, since the arena itself is shared by everyone, it has to be thread safe. If you're planning to write multi-threaded code, and it has to be protected with the mutex. And so here I'm inserting like the chunk into the list, and I set the state in use, and I return and I assign the pointer, and I point to that chunk, right? And here what happens? Here we actually need to check if the old chunk was specified. Copy all the data from it to the new chunk. Find its corresponding pair inside mchunks list and set its state to chunk state free, so it can be reused by others. And that's exactly what this if statement does. We trying to figure out, okay, how much memory was occupied in the old chunk, and if there was some space occupied, we just copy it to a new chunk from the old one, and we change the position of a new chunk, and then we find the iterator of the old chunk, and it shouldn't be and, because otherwise we are doing something very wrong here, and we are not, like, that might be the chunk from a completely different arena, and like many things can happen, but essentially if we hold the chunk, if we were able to pass the chunk here, it should be available in our list, and it should have state in use, because we are currently using it. We haven't put it into the free state yet, but here in this line I put it into the free state, and I set all the data that it holds to 0, right? I have copied it here, and here I set it to 0, which is all right. And yes, and here I have and I set the position to 0, so it can be reused. So we someone who starts using that chunk, it starts using that exactly from position 0, right? And then I return the pointer to a new chunk as a return value. Okay, that's great. Then I have a couple of other helper functions like release memory chunk, and basically I will show you how it's used in a couple of minutes. But essentially, the sun. I don't know whether you can see something, but yeah. Anyway, in order to release a chunk, you have to call release memory chunk. What it does is it basically, yes, locks the mutex, and that's the first thing, because I'm trying to be thread safe, even though I don't have tests for thread safety yet, but I will add them. And we check if the chunk is equal to null pointer. We do nothing. Otherwise, we find the chunk pair in our list, in this list, right? And this is the function which does it. And we set the chunk to the free state, and then we zero all the members inside this chunk, and we set the position to 0. Basically, we do the reset. So after the call to this function, release memory chunk, our chunk could be used by someone else who will be calling this function with a size which is less than the size that this chunk was holding and still holds. Yeah, and there are some helper functions, some other helper functions like total chunks count or empty chunks count, or for example, and we have covered this already for memory allocation and deallocation. So the total chunks count is basically, and I have documented everything here so you can take a look on your own. I will provide the link in the description as well. But basically what it does is returns the count of total chunks that we have in this list, regardless of their state. It can either be in use or it can either be free, right? And then we have another function which is empty chunks count, and what it does is iterates over all the chunks that we have in our list and checks whether the chunk has the free state, and if it does, we return the pointer to that. We increment the counter, and we return it later in order to signify how many free chunks we have in our list. Yeah, and that's basically it. There is nothing strange about it or complex. The only thing that I might mention is the memory chunk itself. It has a couple of helper functions for pushing elements into the memory that it holds. For example, the push, which takes the object and the size, and the same but for add value reference. And then the pop, it just decrements the size, and then we have some helper functions. Those will be used inside the growing array, and so we can actually iterate over the data that we have pushed into the memory chunk. And I will show you, but maybe in a separate video, because I will try to keep it short and informative. It has a remaining size, which is basically how many bytes left in this particular chunk, the total size, and how much space is already occupied. You can compute it basically by saying, okay, size minus remaining, but there is a function for that, right? So I just put it in a separate function because I found it helpful. And there is copy function. It's not documented yet, and I haven't written a lot of tasks for that. I will finish it right after I finish this video, and what it does is takes a chunk and the size, and then this will be the source chunk that you copy the data from, and the destination chunk will be the chunk that we hold, which is essentially this, right? So what you do is you compute the starting position, and then you copy like all the data, and then specify the size into the starting position, and you increment the position of this chunk. And it is has a memory arena class as a friend, so the memory arena can access private members of the memory chunk. Yeah. Okay, and let me briefly show you the tests that I have here. So as I mentioned before, I'm using Google Tests, and here I have a test fixture. I don't know, maybe I can put a link in the description on a Google test and how to use it. I haven't spent that much time on it, but I have some experience. So we have the arena fixture, and we have some context expressions here. We have like a small arena, so we have like different sizes for arenas, right? And then we have a header, chunk header size, which is basically the size of the memory chunk. So this is the test for, and I can just maybe run it so we can see how it works, and we can go through it together. Maybe I will put a couple of breakpoints here and there, so you can take a look. And I don't know whether it will compile or not. I have some other things happening here. This is not relevant to what we are doing currently. Let's see. Okay, great. Here we don't have to do anything. So as you can see, we create an arena, and maybe I can step inside once. So the requested size is 64, right? But the allocated size will be the size of the arena itself would be the size of the page, because we align it. We do the alignment, right? So here you can see that the size would be equal to 1024, which is exactly 1 kilobyte. And we allocated the space, everything's all right, and then we return it back, and then we make sure that it works correctly. Let me jump to a more complicated task, which is get free chunk. And I've tried to explain here the logic what I was doing, but I don't know how well it fits. And obviously it would be better to draw it on the paper or somewhere else, but I just want to keep it here. So what we do, we have a chunk, we have a const expr. This is the size of the first chunk, which is the basically 5 kilobytes, right? But you have to keep in mind that plus the size of the chunk header, thus 6 kilobytes will be allocated, and the arena has the medium size, which means that 1 kilobyte. I'm sorry, 1 megabyte. So we allocate the arena, we allocate all the memory, that's all great, and then we make a request to, okay, get me the chunk. And here, what's actually happening is that we're trying to compute, and I have already total size here, and the total size is exactly what we have. So the total size is 6 kilobytes, right? Because we took into consideration that the size that we requested, which was 5 kilobytes, we have to add the size of the header, and that will be aligned by the page size. So we step inside, we're trying to search for the appropriate chunk, but since we don't have any chunks at all, we skip it and we try to create our own, right? So we create a chunk here and we specify the offset. The offset would be M position, which was 0, plus, since this is the first chunk that we are trying to allocate, M position plus chunk header size. And I can show you the offset. Offset is 24, which is exactly the size of the header. And then there is a starting position, and the chunk size would be 6 kilobytes minus the chunk, the header of the chunk, right? The size of the chunk header, I should say this way rather. We create like an instance of this class, we set all the members, and then we write it down to the memory of the arena itself. So it is pretty important to keep in mind that the chunk itself is stored in the memory allocated for someone to use. So the chunk is a part of it, and we return the pointer to that memory, to that chunk, so it can point to that chunk, right? And then we say M position plus total size in order to adjust M position. So if the next allocation happens, it will start from M position, the allocation for the next chunk. And when I'm saying the allocation, I don't exactly mean like a memory allocation, just because the memory has already been allocated inside the constructor. And yeah, and here we say that we have a new chunk, and we just write to it, right? And then we check whether we had an old chunk, and if we don't need to copy any data at all. We don't need to reset the state. We just return it. And let's come back to our test, and here we check whether like the remaining size inside the arena is equal to the arena size minus the size that has been allocated plus the size of one page, because we have to take into consideration the alignment. And here I get another chunk of this size, and that would allocate me exactly one page. Yeah, I just check whether the remaining is exactly what I want. Then I'm trying to release the chunk, and here I get the chunk back. I put the chunk into the state 3, and then I memset the memory so it is 0, and then I reset the position, right? And then I allocate one more chunk, and yeah, I basically check whether like and here this is quite important, because here what I do is I reuse the chunk that has already been allocated in the beginning here. Sorry, here, right? I'm trying to reuse it because it had free state. Here we released it. Let me find a place. Yes, here we released it, and here we are trying to reuse it. So instead of creating a new chunk, and I can come back to the code that is responsible for that, instead of creating a new chunk here, we search for a chunk with a free state here and get it back instead of creating a new one. Yeah, and then we just check how many chunks we have, and it is 2. Since we don't have to create a new one, we just reuse the one that we have already allocated. And how many empty chunks we have? We have 0, because the one we use, chunk number 2, and the one we have like reused. Thus we have 0 empty chunks left. All of them are in use. And then we release the chunks as we go. And yeah, there are some other tasks, obviously, and I would have to finish the tasks for the chunk state today. Not for the chunk state, but for the functionality, for the copy functionality in particular, because I have added it recently and I didn't really have time to dive into it and test it properly. So I will do it shortly. And yes, okay, I think that would be it. I don't know whether it was helpful, but I've tried to explain my best what I was doing so far, and obviously I will put a link in the description and the command everything well, so we can take a look and like take your time and understand, trying to understand what it does. Again, if you have any comments or questions, just leave them under the video and I will try my best to answer. Yeah, I think that's it, and thank you for watching.